Hello students, I am Tulika Banerjee. Today I bring you the next learning episode on an important unit of the paper titled Fingerprints, that is Automated Fingerprint Identification System or AFIS. In this lecture, you will be introduced to the Automated Fingerprint Identification System, that is AFIS. We will also study how this paperless system is useful in the fingerprint identification and comparison. In addition to it, you will also be studying about the working of AFIS, processing overview and its components. We will wind up this lecture with a conclusion. So dear students, let's start our today's lecture with a brief look at what we will be learning today. First is Introduction to Automated Fingerprint Identification System or AFIS. Next is AFIS, a paperless system. The third module is regarding how AFIS works. Module 4 is regarding processing overview. Module 5 is that of AFIS components, and module 6 is the last conclusion. So dear students, let's start with the introduction of this lecture. Fingerprints are relatively inexpensive to capture. Making an identification of a print from a crime scene may not even require the use of a computerized identification system. The examiner may rely instead on the images from a 10-print card, the latent print, and the expertise of the examiner. Fingerprinting does not require a laboratory for analysis, and fingerprints remain relatively constant over time with the exception of injury. Each person has 10 fingers, 10 unique tokens tied to his or her identity. No two fingerprints have ever been found to be identical. The finger images may be scarred or cut, but can still contain enough information to link the image to the owner. The friction ridges on each person's palms also provide unique images. The automation process has eliminated the need for a print classifier to locate fingerprint cards from a file and compare two physical cards. The searchable database is composed of fingerprint images collected from individuals either by using fingerprint cards or by electronic capture using a device similar to a scanner. The identification aspect occurs when the person is fingerprinted, and the resulting images are searched against the database of fingerprint images on a local, state or national database. It is considered a system because it uses computers and software and can interact with subsystems and other identification systems, including others. Then the AFIS systems. AFIS stands for Automated Fingerprint Identification System. AFIS applications exist in almost every instance in which a finger image is rolled onto a fingerprint card. AFIS systems are the primary identification tool for virtually every law enforcement agency in the United States and the rest of the world. An AFIS system can be immense, such as the 46 million records held by the FBI or Federal Bureau of Investigation, or it can be small, such as when it contains information about only one city. The use of fingerprints as a biometric used for identification of large population groups can be traced back to 1890s when Sir Edward Richard Henry promoted a system of classifying the curving friction ridges and the direction and flow of ridges, patterns and other image characteristics that allowed trained examiners to translate these images into a set of equations that could be understood by any other examiner trained in the rules of classification. The resulting classifications in turn dictated how the records were filed for future retrieval and comparison. A new industry emerged on the ease with which fingerprints could be captured and a uniform method for measuring these images and storing them for future comparisons. AFIS systems searches databases for candidates based on these image characteristics which are related to fingerprints. The characteristics include the points where ridges end, the points where they split, that is bifurcation or a trifurcation, the directions that ridges appear to flow, and even dots. The AFIS system translates what a human eye sees or perceives as a picture, selects key features, searches these features against a database and produces the best match from that database. AFIS systems are not limited to inked fingerprint cards for identification. However, in many areas, the booking officer, instead of using ink and a pre-printed paper stock, can capture finger images on a glass platen of a device called a live scan. The live scan takes a picture of the finger in a fashion similar to rolling a finger onto a glass platen of very compact, very well engineered copy machine. In this process, a picture of each finger of the right hand is taken, then the left hand, then the four fingers for simultaneous impressions of the right hand fingers, then right thumb. This process would be repeated for the left hand and the palms, and a close-up shot or a mug shot might also be taken. These live scan images can then be sent to the Identification Bureau electronically so that within minutes of receipt, the images have been electronically classified for pattern and minutiae characteristics. There are more than 100 of these unique minutiae for each finger and over 1000 for each palm. The database can then be searched for similar pattern and minutiae configurations for 2 or more fingers, usually the index fingers or thumbs. In a parallel process, the subject's name may also be checked against all the names in the master name index database. When the search of each of the index fingers produces the same candidate that the name search produced, there is a very high degree of probability that it is a match. The images are considered to belong to the same person regardless of the sex, age or other information captured in earlier fingerprintable events. It is an ident, an IAFIS term for a positive identification. Latent print processing includes not only a search of the latent print against the latent cognizant database, but also the search of new latent cognizant records against the unsolved latents. If desirable, an unsolved latent print can be searched against to the unsolved latents to identify a serial offender, if that person's identity is unknown. Next in this we have the databases. Identification systems may contain databases of 1, 2, 3 or more records. Examples of these databases include the 10 print database, which contains information on 2 fingers, the latent cognizant database, which contains information all on 10 fingers, and the unsolved latent database, which is the repository for latent print images not identified on AFIS. The 10 print and latent cognizant databases may contain millions of records, while the unsolved latent database may contain hundreds of thousands of records. Each database may be further segmented into an image, a matcher, and possibly an alpha database. The computerized criminal history, or better known as the CCH database, contains information about the subject's activity for fingerprintable events. Although the term criminal history implies that only criminal activity is recorded, this is not always the case. Any fingerprintable event is recorded in this database. For example, job applicants who have been fingerprinted as a part of a background check have a history stored in this database. The history or rap sheet includes the date when the person was fingerprinted, the person's name and other biographical information, aliases if any, and other identification information. Then in this we have a second process that is called as the identification process. Identification systems match finger image characteristics, not persons. When a person is arrested and fingerprinted, an AFIS search is conducted. If there is no match based on the finger image characteristics stored in the database, the record is assigned a state identification number or SID. The CCH for the subject would include his or her name as it appears on the 10 print record or as it appears in the online booking system or the OLBS, a computerized method of collecting and forwarding arrest history and information. If the same person is arrested again but presents a different name, the CCH will return identification with a criminal history that shows another name. That is, the finger images of the person now in custody match a person with another name, which means that both names belong to the same person. The arresting agency will have to determine which identity, if either, is correct. In the past, clever recidivists could use this ploy with some success, since not all the criminal history searches were fingerprint based. This loophole is quickly closing as AFIS systems become more powerful and connected. The 10 print or the TPID or identification database contains the image record characteristics that are used for searching. There may be the records from 2 index fingers, the 2 thumbs or other combinations. Some AFIS systems combine the index fingers and thumbs in their 10 print searches. The latent cognizant or the TPIC or criminal database contains the fingerprint images or the characteristics of all 10 fingers. The image captures as much as image characteristic information as possible, such as that contained in the nail to nail roll. The quality of these 10 images is important since they are associated with arrestees who may not be cooperative at the time the images are taken. For searching latent prints found at a crime scene, the need for a database that contains all 10 images of superior image quality is a nail to nail roll is readily apparent. So, starting with the first, we have 10 print. The process begins at a local police agency when an individual is arrested. The appropriate arrest information is entered into the local agency's booking system. Fingerprints are taken by ink and roll, or more increasingly are electronically captured on the FBI certified equipment. The proper finger placement and the fingerprint image quality are checked. The palms of each hand of the subject are placed on the platen of the live scan machine and those images are captured. Digital mug shots or close-up shots may be taken along with descriptions of scars, marks and tattoos abbreviated as SMT, and entered into the system if necessary corrections are made. The images and biographic data can be mailed, faxed or sent electronically to the state or local identification agency that operates the AFIS system. To send the information about the subject electronically, it must be locally formatted following state and national standards into an electronic arrest transaction that consists of 10 rolled finger images and 4 plain impression fingerprints, mugshots, SMT data and the individual's arrest and biographic data. This is transmitted over secure data communication networks using secure encryption. The data is checked for completeness and proper format before it is accepted for further processing. If data is missing or incomplete, the image quality is unacceptable or the record is unacceptable. The inquiring agency is instructed to resubmit the record. Correcting the problem may require re-rolling the subject, completing all mandatory fields, retransmission, etc. The arrest data is separated and sent to the CCH system to initiate the identification process. The individual fingerprints and the plain impressions are displayed on an AFIS workstation screen. A fingerprint technician then performs a number of operations, including validation of finger placement, image quality checking, pattern assignment and image centering. The arrest transaction is entered into an updated and improved AFIS for searching against the state fingerprint database. The minutiae of the finger image characteristics are identified by the coder and the search is initiated. Possible matching images are presented on the computer screen next to the submitted image in a side-by-side format. Next is the latent print process. In latent print process, latent print cases are entered into the AFIS system at a central site or regional or remote site connected to AFIS. The latent print may have been collected by a crime scene specialist who has a special training to recognize and capture latent print images, or it may have been collected by a patrol officer who may be less skilled and who may have less equipment, or the print may have been collected by another local agency and forwarded to the receiving agency for a search against the database. The latent image is evaluated by a trained latent examiner and a determination is made as to whether the image is of value, that is, whether the image has enough identifiable characteristics to make a positive identification. If the image is determined to be of value, a search of the AFIS database is initiated. The alphanumeric data related to the case is entered into the system. This data includes the case number, originating agency, region to search, crime type, the ID number of each latent print and other information such as sex, pattern type, race and finger number. Defaults are built into the system to provide a complete database search known as the cold search. The latent fingerprint is manually positioned under either a digital camera or the scanner of a latent input workstation by a latent examiner, and the image is digitized. The examiner can check for image quality and if not satisfied, redigitize the image. Next, the examiner with the help of the coder identifies and marks each minutiae on the image of the fingerprint displayed on the input workstation, selects orientation and repeats the process with each additional latent print. The function of the coder is to identify or code the minutiae in the finger image. The ridge endings, bifurcations and direction provide unique identification points. Intervening ridges between minutiae may also provide unique information. The minutiae points are identified by the coder and displayed on the screen. The examiner may choose to add additional minutiae points not found by the coder or remove points considered as marginal. After all latents have been entered, the latent examiner checks the work and launches the case. The latent fingerprint is searched by the matchers against a latent cognition database containing hundreds of thousands of even millions of images. Candidates for a match are made available at a verification workstation at the originating central or remote site and are retrieved for verification. Print images of the candidates are displayed side by side with the latent print image or with the image of the latent print. Next, we have the unsolved latent search. Not every latent print search will result in identification. While actual figures may vary, the rule of thumb is that only 10 to 15% of cases and 2 to 3% of latent print searches will result in identification. Many latent print examiners will search the latent print more than one time to allow for differences in image capture, manual minutiae placement or other variables. After a reasonable number of additional searches, the examiner either deletes the AFIS case or saves the latent print information into the unsolved latent or the UL file. The UL file, which is always smaller than the 10 print database, contains case information, case images and minutiae or the minutiae characteristics. When a new 10 print inquiry is made, the 2 index fingers are searched against the 10 print file and all 10 fingers can be searched against the UL file. If there is enough minutiae match to produce a candidate, the latent print case will be marked for review by the examiner. Some search all 10 print records with the notion that although the record and images already exist in the database, the newer images may differ slightly in terms of clarity, distortion, number of minutiae, etc. These new images may produce a minutiae match where none existed before. Then we have the latent or the latent search. If no identification is made on the LTTP searches, the latent print examiner still has other search options available. The latent print examiner could initiate a new search in which the unknown latent print is searched against a database of unknown latent prints. Also referred to as unsolved to unsolved searches, the latent or latent searches provide an opportunity to determine if crimes are being committed by the same person enough if the person remains unidentified. Latent print examiners can initiate a LT or LT search, view the candidates and determine if one or more of the candidates matches the searched latent print. If there is a match, the examiner can notify the inquiring agency that another agency or investigating or the investigator within the same agency is working on a case in which matching latent prints were found. This collaboration can ultimately lead to an identification and arrest. The goal of the identification process is to make as much identification as possible with the given resources. In the world of 10 print applications, this process is quantity driven with the need to respond to a request with a complete criminal history or rap sheet within a limited time period. For latent print applications, the goal is to make as much identification as possible by searching millions of records and producing a candidate list that is likely to contain a match to the latent print image. The first component is the physical layout of AFIS. The main components of an AFIS system includes the matchers, coders, random array of independent drives, that is RAID storage arrays, and the various databases. The Ethernet connects the AFIS system to various input and output devices at other locations. A live scan is an example of an input device. The Ethernet also connects the AFIS system to the computerized criminal history file, or the CCH file. Next is AFIS hardware. A card scan takes an image of a 10 print card much like a high quality copier, capturing finger images for searches against the AFIS. The inquiring agency sends the resulting electronic images to the Identification Bureau, where they are electronically mated with the subject's biographical information, which was sent through the online booking system, or the OLBS. If the record was sent to the Bureau by live scan, the scanner station or the quality control station, which handles records that need special processing such as searches with missing or bandaged fingers, transposition of hands, or mismatch of pattern information, can be used to ensure the quality of the image. If the image does not meet the Bureau's criteria, the Bureau notifies the inquiring agency and requests resubmission or rerolls. The next component is the coders. The job of coders is to identify, that is, extract features from finger images such as minutiae, direction of ridge flow, distance between minutiae, and number of ridges between minutiae. Coders work either on the input workstation or on a separate computer. They have a key role in the identification process since they extract the image characteristics used by the matchers in searches. Incorrect feature marking can lead to false negatives, where a print is improperly matched. The next is RAID storage. The redundant array of independent or inexpensive drives, or RAID, is a feature of AFIS that allows a number of smaller drives to be combined together to make a larger array, which provides additional features such as improved performance and data redundancy. The redundancy of smaller disks, faster input or output, increased capacity, and better security make RAID storage desirable for large AFIS systems. The next component of AFIS is matchers. There are multiple set of matchers for various types of searches. When a search is initiated, the extracted image characteristics of the search record are compared or searched against the extracted image characteristics already on file. Scores are assigned to the candidates produced by the search that indicate the relationship of the image characteristics on file to the image characteristics of the search print. If 75 minutiae of a search image exactly match 75 minutiae of an enrolled record in the matchers, the enrolled record would be given a very high score. It might have more than 75 minutiae, but the large number of matching minutiae creates an extremely high probability that the two images are from the same person. There are three major components to the matcher subsystem: the matcher controllers, the string controllers, and the matchers themselves. Each has a specific function in the identification process. The matcher controller is the computer that controls the operation of that matcher subsystem. Transactions from the AFIS system and responses back to it are channeled through a matcher controller. Fingerprints are relatively inexpensive to capture. No two fingerprints have ever been found to be identical. The finger images may be scarred or cut, but can still contain enough information to link the image with the owner. The friction ridges on each person's palms also provide unique images. AFIS stands for Automated Fingerprint Identification System. The automation process has eliminated the need for a print classifier to locate fingerprint cards from a file and compare two physical cards. The searchable database is composed of fingerprint images collected from individuals either by using fingerprint cards or by electronic capture using a device similar to a scanner. The identification aspect occurs when the person is fingerprinted and the resulting image are searched against the database of fingerprint images on a local, state or national database. Students, this brings an end to the chapter. I am sure now you all are familiar with the concept of Automated Fingerprint Identification System or AFIS. Please review the lecture from time to time so that you have command over this topic. I hope you all have understood the underlying concepts of this chapter. Do keep in mind what we discussed today. I'll be back with one more lecture in this series. If you want to learn more and enhance your knowledge, you may log on to our website www.cec.nic.in for MCQs, quizzes, LORs, etc. Thank you for your time today. I'll see you in the next lecture. Keep learning and goodbye.